Everything in the universe is in motion. Even you. As you view this program, you are riding on the Earth as it spins on its axis, revolving around a star which is orbiting the center of the galaxy that is traveling in a universe that is expanding. Motion is everywhere. Because of this, motion is an important quantity that astronomers seek out in their observations. With spectroscopy, they can tell not only if an object is moving toward or away from the observer, but if it's spinning, or expanding, or orbiting another object.
Take a spectrum of an astronomical object. Besides disentangling these patterns, figuring out what the object is made out of, there's also a lot of useful information because of the Doppler effect.
The Doppler effect is the apparent change in wavelength of a wave depending on the motion of the source toward or away from an observer. Astronomers observe this effect with wavelengths of light, but we experience it with sound as well.
If you've ever stood there on a street corner and you've heard an ambulance go by, the first thing you hear is a very high-pitched noise, as it's, say, coming from your left and passing by you. And as it passes by you, what you hear are lower frequencies, a very low-pitched sound. So what is happening in that instance is, as the ambulance is coming toward you, the sound waves that are getting transmitted by the horn on the ambulance, the sound waves are compressed. As it goes away from you, those sound fronts, you could say, get stretched out. So it corresponds to a longer wavelength and a lower pitch. So you hear a lower sound. The same principle can be applied to light. If you have something coming towards you, you will see it, the spectrum get shifted, but towards shorter wavelengths, and those shorter wavelengths are mainly blue wavelengths. So it gets shifted, they say, toward the blue. If something, and this happens often in astronomy, if something is going away from you, it's going to get shifted toward longer wavelengths, and that's mostly toward the red.
These shifts are classified by the direction they move within the spectrum. Objects moving away from us exhibit shifts to the longer wavelengths. We call them redshifts. Objects moving toward us exhibit shifts to the shorter wavelengths and are called blue shifts.